Hello everyone, I am Dr. Millie and you are watching Erudite Classes. In last video we have seen how the tetrahedral voids and octahedral voids are created and the coordination number of these voids. Coordination number of octahedral voids were found to be 4 because this void is made by the 3 balls downside of 1 ball upside. On the other side, octahedral voids ka coordination number was 6 because it was covering 3 ball over 3 ball. So this way we have understood what these voids are basically. In this video we will be understanding where these voids are situated, and after knowing their location we can understand how many voids can be found in a particular unit cell. We are considering here FCC type of unit cell, and we will see how many voids and what type of voids are present in a unit cell. Okay, unit cell which we are taking here is FCC type of, and one by one I will be telling you the location of these voids. Okay, so let's see. I am starting from the first, the cube, basic cube I have already drawn here. This is your cube and these are the centers of the various phases. So this is the center of this phase, back side ka this one and this one, and I am going to connect these phases, all 4 side phases. I am going to connect this phase, this atom with this atom with the center of this phase, this one, center, this one, and the center, this one. So this way I have connected 4 of the atoms, 4 above and downside. So here you can compare that this is octahedral void, don't you? So this is the center of the cell, and octahedral void is always present at the center of unit cell. Which type of? FCC unit cell. So one octahedral void, you can find one octahedral void at center. Okay, one octahedral void we have got at center. What is another location of octahedral voids, and total how many octahedral voids will be there in a single unit cell? That we are going to see. To understand where they are, what are the other places where these octahedral voids are located, and I have drawn one more unit cell here, and I am going to show you the another octahedral voids also. So second thing is, here I am getting the octahedral voids. Apart from that, we are getting the octahedral voids at the edges also. So I am going to connect this edge. I am going to expand this unit cell, because it will be, this will be the center of this unit cell, this particular phase, this will be the center of this particular phase. Okay, and this will be one atom at the corner side, center of this phase, and downside also there will be one phase now. So this is the center of this phase. Now can you see here, this and this we are connecting, and this is the octahedral void present at the edge. So you can see there are 2 possibilities where the octahedral voids can be present. At the center, one which is there inside the particular unit cell. So this particularly this octahedral voids is not being shared by this particular unit cell to anyone else, to any other unit cell, but this void is there in this cell, unit cell is there in this unit cell, upside unit cell, and this unit cell. So 1, 2, 3 and 4. This is shared just because the edge is shared by the 4 other unit cells. So every edge of the void of the unit cell is connected with the 4 other unit cells. Hence, each void which is present at the particular edge. So total, just let me count how many edges are there in the unit cell. So in the cube there are 12 edges. How many edges are there in cube? There are 12 edges. One octahedral void on each edge. So total at octahedral voids कितने हुए? 12. Okay. Now shared by 4. So ultimately number of octahedral voids will be 12 divided by 4. that is 3. So 3 octahedral voids ultimately will be present at the edges. 1 octahedral voids is present at the center. So total voids कितने हुए? 1 from the center and 3 from the edges. So I hope it is clear. Total हो गए 4. So total number of octahedral voids in the unit cell will be 4. Overall, 4 octahedral voids will be present inside a single unit cell. Which type of? FCC kind of unit cell. So remember that what were the number of atoms in the unit cell called FCC type? We know that from the corner total number of atoms in the unit cell, total atoms in FCC unit cell, it was 1 from the corner plus 3 from the center of phase. How many phases were there in cubic unit cell? There are 1, 2, 3, 4, 5 and 6. 6 phases. The atoms which is present at the center of the phase was connected with this unit cell as well as to the nearby unit cell. So the contribution was half. And just because 6 atoms were there and contribution was half, we got 3 atoms overall. So the total 3 atoms from the center of the phases and 1 atom from the corner. Total number of atoms were 4. So total number of atoms is equal to the number of octahedral voids here. So I can say that number of octahedral voids in unit cell will be equal to the number of atoms in that unit cell. So is it clear to you? I can learn it like on. How I can learn? The number of octahedral voids will be equal to the number of atoms in that unit cell. So I hope it is clear to you. You can visualize now that where these are located. Where these are located? At the edges. 12 edges are there. Every edge is contributing itself from the 4 to 12 divided by 4. So overall there are 3 octahedral voids inside the unit cell. That unit cell. Inside this unit cell. For every edge is contributing towards the 4 other edges also, 4 other unit cells also. Same way, there is one more at the center. So total milake 3 from the edges and 1 from the center, which is not being shared by anything else, that is inside the unit cell. The total number of octahedral voids 4. Okay. Now let's understand where the tetrahedral voids are located. Here is the cube, and I'm going to draw it like the center of this face, center of this face, center of this face. Okay, and I'm going to draw this ball also. This is atom here. So here we have 3 atoms. Can you see them? 1, 2 and 3 atoms, and this is one ball. So this is your tetrahedral void created here between 1, 2, 3 plus 1 balls. So this is the location of tetrahedral void, where it is lying actually. So you can see here it is lying now. So if I am using one diagonal, I am connecting one diagonal here. So here is the diagonal. On this diagonal, on the diagonal of this cube, this void is obtained. So this is the location of tetrahedral void. If you remember, when we were deriving the relationship between the A and R for the BCC type of crystal, we have calculated this part. याद है? तो हम लोगों ने ये part याद किया था, and this A, if it is A and B, so actually it is found at the 1/4 distance of A and B. So this is found at the 1/4 distance, and at a particular diagonal we will be getting 2 octahedral voids. One this side and one this side. So 2 tetrahedral voids are present at each body diagonal in the cube. How many body diagonals are there in the cube? there are 4 body diagonal. Can you see there in the cube? Look at this again. So here is your cube. Okay, one body diagonal, second body diagonal, third body diagonal, यहाँ से यहाँ, from this side to this edge and this to this. So total overall 4 body diagonals are there, and each body diagonal is having 2 tetrahedral voids on it. So total number of tetrahedral voids in this cell, in this unit cell, is 8. Tetrahedral voids will be equal to 8. And how many atoms are there in the FCC crystal? Number of atoms in FCC unit cell is equal to 4, which we have already calculated. 4 from the corner. Okay, 4 plus 4 divided by 8. That is, every atom is contributing 1 by 8. So from the corner there is 1 atom, and from the center of the faces there are 3 atoms. So 1 plus 3 ka combination, 4 atoms are there overall. But the number of tetrahedral voids created are 8. So how they are related with each other? That we can say that number of tetrahedral voids will be equal to 2 into number of atoms in unit cell. Okay, so we can write it as T2n. So you have to learn only O is equal to always n, and T is always equal to 2n. Okay, so this way you have calculated the number of octahedral voids and tetrahedral voids present in any crystal. If a question is given to you, suppose I am giving a question to you that there are 2 atoms A and B. A is present at corner only, and B is present at each, I can write out, in each tetrahedral void. Tetrahedral void. What will be formula of unit cell? So if A is present at the corner, total number of A atom will be 1, because corner पे there are 8 atoms and each is contributing 1 by 8. So the atoms which are present at the corner will be 1, and atoms which are present in each tetrahedral voids, if 1 atom is there overall, so we know that T equals 2n, means tetrahedral voids will be 2. So it is covering each tetrahedral voids. So it is covering 2 tetrahedral voids. Means what? Means there are 2 B atoms. So AB 2 will be the formula of the compound. This way we can calculate the formula of the compounds made by the combination of various species, various kind of atoms. This B is going inside the tetrahedral voids, so it must be smaller. So in the next video we will be understanding what is the relationship between, मतलब ये A और B में ये B, this B can be fitted inside the A, the grooves of the A, or not, because the size of the void will totally depend on the size of the atom. So it will depend on, suppose this is the atom size, the groove will be this. If the atom size I am decreasing, the groove is also decreasing. If atom size I am increasing, look at this, the groove is also increasing. Means the groove or the void, the size of the void, the radius of the void will totally depend on the size of the atom. But how they are related with each other? The size of tetrahedral voids and the size of octahedral voids, how they are related with the atoms in which they are formed, or by which they are created. So I hope this video will be helpful for you to locate the tetrahedral and octahedral voids in the unit cell. And you can count also how many tetrahedral and octahedral voids are present in your cube, yeah, in your unit cell. I hope this will be very useful for you to understand the concept. If you like this video, please hit the like button, share it and subscribe it. Thank you very much.